In the last video, we talked about what it means to incorporate public transit schedule data into network analysis and how that might be useful to understand how easily people can access important destinations by transit. In order to do those network analysis calculations, we need to create a network dataset that includes the public transit data. In this video, I'm going to walk you through that process. We'll start with GTFS public transit data, convert that to the public transit data model, prepare street data and connect the transit data to the streets, create the network dataset, build it, and then test it out. Before we dive in, I just wanted to remind you about the Network Analyst public transit data model. This is the set of feature classes and tables we use for storing the public transit stops, lines, and schedules. We need our data in this format before we can create the network dataset. For more details and descriptions of this data model, please refer to the earlier video. Here's an outline of the workflow for creating a network dataset with public transit data, which also serves as an outline for this video. First, we create a file geodatabase and feature dataset. Then, create the data model feature classes and tables using the GTFS to public transit data model tool. Then we need to prepare the street data. Then we need to connect the data model features to the street data using the Connect Public Transit Data Model to Streets tool. Then we create the network dataset using a provided template. Then we customize the network if we need to, build the network, and then finally test it out using service area. I'll talk about each step and then show you a demo in ArcGIS Pro. This video pretty much follows the steps in the tutorial from the ArcGIS Pro documentation, which you can find using the link in the slide and these notes pages if you download them. Let's start out by creating a file geodatabase and feature dataset. A file geodatabase is a special type of Esri database for storing geographic data, like feature classes and tables. It's just a container for data. Your network dataset must be in a file geodatabase, and it's best to create a fresh one just for your network. A feature dataset is a subdivision within a file geodatabase meant for storing spatial data with a shared spatial reference. You can think of it sort of like a folder, although technically that's not what it is. Network datasets must be created inside a feature dataset, so that's why we have to create one. Here I am in ArcGIS Pro. Now I'm going to create a file geodatabase and a feature dataset that we'll use to create the network later. So let me just go into the catalog pane here, and I'll right-click my project folder and say New File Geodatabase. So this just creates it, and it makes it so I can rename it whatever I want. We'll just call it Transit Network. Okay, so the file geodatabase is created, and it's currently empty. Now I need to create a feature dataset within this file geodatabase. So if I right-click it, I can choose New Feature Dataset. And this opens the Create Feature Dataset tool. Now I need to give it a name. I guess we'll just still call it Transit Network. And then I need to choose a coordinate system. Your choice doesn't particularly matter, but it's good to choose something that makes sense for your geography. I'm going to go ahead and choose something that I'm using for some other data in my Cincinnati area, which is where I'm going to be creating the network for. So I'll choose my Ohio State plane. And then I just run the tool, and it will create the feature dataset. All right, so back in my catalog pane, I can expand my file geodatabase, and you can see that my feature dataset is now in there. And that will be where the network dataset ends up being created in a later step. The next step is to create the data model feature classes and tables using the GTFS to public transit data model tool. Recall from our earlier video that you can use the GTFS to public transit data model tool to convert GTFS data into the feature classes and tables of the public transit data model. Please refer to that earlier video for more details on this tool. I'll go back to the geoprocessing pane, and I need to search for GTFS to public transit data model. I'm going to open this tool. Now I need to pick my GTFS folders, and I'll use the Cincinnati tutorial data. And then I need to choose the target feature dataset, and that's the feature dataset I just created. and I'll run the tool. The tool is finished, and it's added all of the feature classes and tables from the data model into the map. Again, please refer to that earlier video for the details about what all of these feature classes and tables mean. The next step in the process is to prepare your street data. You need to include street data in your network dataset in addition to the transit data. That's because people will walk along the streets in order to get from their origin to the transit stop, to make transfers between lines, and to get from their final transit stop to their destination. You need to acquire some street data covering the same geographic area as your transit system and ensure that the data is of good quality, is well connected, and has the necessary attributes. Preparing the street data is the most manual part of this whole process and probably the most prone to errors. Street data can vary in quality substantially, and it's really important that you acquire good data and check it carefully. The accuracy of your analysis is only as good as the underlying data. When we create our network dataset, we're going to be using a provided template that comes with the Network Analyst tutorial data. This template requires a field in the street data called restrict pedestrians with values of either Y or N, indicating whether pedestrians should be restricted from traveling on that particular street. That allows us to prevent pedestrians from walking on highways and stuff like that. Note that this is a requirement of the particular template we're going to be using. If you want to construct your network dataset from scratch, you don't need to have this field, and you could construct things however you want. But to use the template, you need to add and populate the restrict pedestrians field. The street data also needs to have a field called road class. Once you've investigated your street data and corrected any problems, you need to put it into the feature dataset where the network is going to be created. You can just copy it if it already has the right spatial reference, but otherwise you need to use the project tool to ensure that the spatial reference is converted correctly. For my network, I'm going to use the streets data that came with the Network Analyst tutorial data. So the first thing I want to check is just the basic geographic coverage of this data. Make sure it covers the same area that my public transit data does. So let's just add it to the map and take a look. All right. So it looks like the extent of this street data set more than covers the public transit data, so that's good. Now I want to check if the data itself looks like it has good quality and covers all of the roads that seem to exist. So one way to do that is to just check whether it kind of matches the base map. So let me zoom in a little closer. This data looks pretty comprehensive. You can see that it's got all the highways, not that we really want those anyway. And it's got some of these little, that looks like, I don't know, a university quadrangle or something like that. There looks like there's a couple of things that might be driveways that are not included in this data. And if that mattered to me, I might want to try to digitize those in. But in general, it looks like the data is pretty good quality. It seems to be covering everything and seems to be present and correct. Now, just from eyeballing it, it looks like the data also intersects at all of the intersections like it should. There's not little gaps and dangles causing it to not actually touch at the endpoints of the intersections. So if I use the select tool, I can select little pieces, and I can see that the data also appears to be split at the locations of these intersections. So instead of having, for example, one long feature that just has vertices at the locations of these intersections, it actually is broken up and has endpoints. And actually, you can create a network with either of those situations, but having everything broken up like this is a little bit easier to deal with. Now, if you're creating a network for some particular analysis or production level work, you really should do some more detailed quality assurance checks on your data than what I've just done now. For the purposes of this demo, I'm not going to go into any more detail than what I just did. The next thing I want to check is the attributes of the street data. So let's open up the attribute table and take a look. So it looks like this data has some information about the street names and some other fields. Now, in order to use my network dataset template, I have to have this field here. It's called restrict pedestrians. And it's a text field, and it has two values, N or Y. N means no, don't restrict pedestrians from this particular street, and Y means yes, do restrict pedestrians. So let's take a look and maybe zoom to this street and just kind of see what kind of street it is. All right, so this just looks like some ordinary street, and pedestrians are not restricted. And this one, all right, this very clearly looks like a highway ramp, and so it makes sense that this would be restricted to pedestrians. So this field conveniently is already set up and configured for you because this is tutorial data after all. But in your data, you need to figure out how to calculate this field. So if it doesn't exist in your data, you need to create it, and you need to populate it with these y and n values in a way that makes sense. So you could use some information about road class or whatever other attributes you have in your data in order to make this sensible. Now I also have to have a field called road class, and it has to be capital road underscore capital class, and it has to be of type short, just the way that this tutorial data is constructed. And that's because the network dataset template is also expecting this field. If you have road class in some other format, you'll need to transform it into something that's formatted like this. All right, so this data looks good, and we should be able to use it. Let me just clear the selection. And now I want to copy this data from the original location, which is just in this geodatabase that came with the tutorial data. And I want to copy it into my feature dataset where I'm going to create the network. But I can't just right-click and copy and paste it because it actually doesn't have the same spatial reference. So remember earlier when I created the feature dataset, I used this Ohio State plane spatial reference. It's a projected coordinate system for the feature dataset. But my street data is actually, it's just in a geographic coordinate system using WGS 1984. So I need to use the project tool to project the street data into that coordinate system. That also will copy the data at the same time into the feature dataset. So in the geoprocessing pane, I can just look for project. And I need to make sure it has the same name, so it has to be called streets. Otherwise the template won't work. All right, and this has automatically populated the output coordinate system because it knows it's going into a feature dataset, and it's using a geographic transformation, which is the appropriate thing to correctly project it without messing up the locations of the features. Okay, the project tool is finished. You can see that my street data is located in the transit network feature dataset just like I wanted. Next, we need to connect the transit data model feature classes to our streets. We're going to go one step further with the transit data model this time in creating the stops on streets and stop connectors feature classes. These connect the transit stops to the street features that you want to use for your network. The connections follow a specific set of rules to correctly model transitions between streets and transit lines in the network dataset. You can do this using the Connect Public Transit Data Model to Streets tool. This tool takes your existing data model feature classes and tables and combines it with the street data to create the stops on streets and stop connectors feature classes. You can even use a SQL expression to prevent snapping stops to certain streets. This is useful if you have fields in the street data indicating that pedestrians aren't allowed, so you can avoid accidentally snapping transit stops to those streets. All right, let's connect our line variant elements and stops to the streets features. I'll search for Connect Public Transit Data Model to Streets. I need to set the target feature dataset. And I need to tell it which street features to use. So I want to make sure that I'm using the street features that are in my feature dataset, the ones that I copied into there earlier. I can set a search distance. This is how far to check from the public transit stop to the street, and anything that's bigger than this distance won't be found. I'll just leave it with the default. And then I can also set up an expression. And in my case, I want to make sure I don't snap any public transit stops to any street that's restricted to pedestrians. I can set it so the restrict pedestrians field is not equal to Y. So if restrict pedestrians is N or no, or it's got a null value, that means that it's valid for me to snap my stop to it because pedestrians can travel there. The only case that I want to exclude is where it equals Y or yes, because pedestrians are restricted, and I don't want to have a public transit stop located on some street where pedestrians can't walk. And I run the tool. Tool is finished. And in my transit network feature dataset, you can see that it's created stop connectors and stops on streets as new feature classes, and it's added them to the map. Let me zoom in and just show you the structure that this has created. All right, here's a good example. So the pink here represents the line variant elements, or the transit lines that were created earlier, and the gray is the streets. And these pink dots are the stop locations. Those were the ones generated earlier. And the tool we just ran snapped the stops to the closest street feature, and it generated these little straight line connectors connecting the true stop location with the snapped location. And this makes it so that a traveler could walk down the street, get to the stop, hop onto the transit line, and then ride away. Now it's time to actually create the network dataset. Using the Create Network Dataset from Template tool, you can automatically create a network dataset with all the settings configured using the XML file provided with the Network Analyst tutorial data. As long as your input data matches the template's expected schema, this should just work. Your input data needs to have the expected feature class and table names and all the required fields. You don't have to use the provided template. You could create a network dataset from scratch using the Create Network Dataset tool, and then configure all the settings manually if you want to. There's nothing wrong with this approach, but creating it from the template is probably easier. You can still modify all the properties after you create it from the template anyway. You might be curious about where the provided network dataset template came from. When I was creating the tutorial, I first manually created and configured the network dataset using public transit data with all the settings I wanted. Once I was happy with the network and was sure it was working properly, I used the Create Template from Network Dataset tool to generate the XML template file. With this template, I can now create new network datasets anytime with all the same settings as long as the input data has the same schema. You can do this yourself if you want to, if you think you'll need to create many network datasets for different geographies, and the provided template isn't exactly what you need. So you could modify the network dataset properties for your needs, create a new template, and then just use that template in the future to create more networks. All right, let's create the network. So I'll search for the Create Network Dataset from Template tool, and I need to tell it what the template file is. So I'm going to use the template that came with the tutorial data. It's this transit network template.xml file. And I need to tell it to put the network dataset in my feature dataset that I created for this purpose. And then I just run the tool. You can see that transit network _ND is a network dataset layer, and it's been added to the map. And in the catalog pane in my feature dataset, you can see the network dataset here has been added, and you can tell by the little network dataset icon. Up next is to customize the network dataset if needed. After the network dataset has been created, now is your opportunity to examine all the network dataset properties and settings and customize them to suit your needs. You might want to add some new travel modes, update the connectivity policy, or make other customizations specific to your analysis needs and goals. I'm not going to talk about this in detail right now because all these detailed network dataset settings are the subject of the next video. Once you're satisfied with your network, it's time to build it. The network dataset has been created, but it isn't actually usable until you build it. You can build the network using the Build Network geoprocessing tool. The build process creates the internal logical graph in the network and does some error checking. You have to rebuild the network anytime you update the source feature geometry or the network dataset properties. You might get a few build errors when you build the network. You need to examine those and either fix them or ignore them if you've determined that they're not really important. There's some more information about this in the tutorial. If I want to review or change my network dataset settings, I can right-click the network dataset and click Properties, and that will open all the property pages for the network. I'm not going to do that right now because, again, I'm going to talk about this in much more detail in the next video. Now I want to build the network. So if I right-click, I can choose Build, and this opens the Build Network tool, and then I can run it. All right, the tool's finished. It only takes a few minutes to build a network at a metropolitan scale like this one, but if you're going to build a network that covers, say, all of North America or Europe, that can be a very lengthy process, so make sure you plan ahead. Notice that the Build Network tool completed with warnings. And the warning message I get says, the network was built, but with some errors. Error details are at, and then it gives me the name of a file. So this means that something happened when I built the network, and there's one or more problems that I need to investigate. So I need to open up this file. So there's only a few errors in here, and they're all the same one that says geometry is empty, and they're referring to a particular object ID in the stop connectors feature class. And typically what happens is the public transit stop and the snapped version of that stop that snaps to the streets are coincident. They're in the same location. So when they're in the same location, it generates a stop connector feature with null geometry because it has no length. And if this was a really widespread problem, I would probably try to correct those somehow. As it is, there's just a few of them, and I don't think this is going to be a really big deal for my analysis. If I wanted to, I could look up the object ID of each one of these stop connectors and the stops that it's connected to, and I could try to make some edits. But for now, I'm just not going to bother. We finally reached the last step. It's time to test out the network dataset. At this point, the network dataset should be ready to use. The easiest way to test it out is to create and solve a service area. Service area makes it fairly easy to see if the transit lines are being used, since usually the service area polygon follows the transit lines, and it will change depending on the time of day you solve it. All right, finally, time to test out our network dataset and see if it works. I'm going to create a service area layer, so I go to Analysis, Network Analysis, and I can confirm that my transit network is the chosen network data source. So when I create my service area layer, it will reference that transit network. All right, the service area layer has been created. And if I look at the settings, I can confirm that public transit time has been chosen as my travel mode. And I'll just set the cutoff to something large like 45 minutes. That should be plenty of time to get on the transit. And I need to pick a time of day. So I confirmed earlier when I was looking at my GTFS data that I can use either a specific date and time or I can use a day of the week, a generic weekday. So let's just pick a generic weekday. Tuesday is fine and 8 a.m. is fine. So we'll just leave that as a test. And now I need to create a facility. So I'll just use the Create Features pane, and I'll drop a facility in somewhere in downtown Cincinnati. Save my edits. All right, now let's solve the service area and see what it looks like. Oh, look at that. Ooh, isn't that pretty? And you can see how it has these little areas that kind of snake out along the transit lines because the area reachable is extended by the transit lines. And there's even some disconnected areas. This is at the airport, it looks like, and so there's probably some service that goes express from downtown out to the airport with no stops in between. So when you see these disconnected blobs, that's pretty common and normal. Now let's choose a different time of day and see how it changes. Let's, for example, choose, I don't know, 2:30 in the afternoon. And I'll solve it again, and the result is going to change. Now see, we can't get to the airport at this time of day within 45 minutes, or any of this area down here. It's pretty neat, huh? So it seems like our network is working as expected. That's great. In a future video, I'll talk about how to handle these differences in the results depending on the time of day, and I'll also talk in much more detail about the specific settings within the network dataset because I think it's important to understand those.